Hello everybody, this is update to the progress so far on the F-16 HOTAS extension which I am making for Saitek Pro Throttle. It's a part 2. So hardware wise I haven't made any progress, but I made quite a bit of progress on the software part and the logic of the circuit and other stuff. So I just want to walk through a few of them, and I think those are very important to go to the next step of creating the PCBs and related stuff. So in this entire exercise I also went through lots of redesigning and reworking of all the components, and had to change few components here and there, made few logic changes and also part changes. So as you can see, I also redesigned this particular HOTAS extension a bit. I made it a little longer now. Earlier it was 9 centimeter, I think. Now it is almost close to I think 13 or 14 centimeter. That actually gave a nice spacing on these buttons and toggles. The reason was I need to go from 16:2 LCD to 20:4 LCD, which was a little bigger in size, and it was not fitting in the previous form factor of the extension controller. Now these are the final kind of layout which I am planning, with 5 rockers, 5 toggle switches, and 4 program buttons, one joystick button here separate, and this is 5-way joystick plus a cursor joystick with the push button, and 2 potentiometers plus one mode selector switch. I'll explain this a bit later. And this is technically making sure that the toggles, these are all always on sticky toggles, so this allows me to make them behave like a momentary toggle switches. Means if you switch it on, if it is on the momentary mode, it will just blink the button for a moment and switch off, and same thing. But if it's on a hold mode, then it just stays on, and the joystick button stays on as long as the toggle is switched on its direction. So yeah. Coming over to the this was the earlier breadboard design I had, where I was working with 8 rows and 4 columns for input matrix, but what I realized was and also while writing the arduino code, I came to a few ideas and few changes, which was and I was trying to optimize the code as much as possible, not to have any delays or not to have any additional logics or or anything of the sort, which will take much longer, and I don't want to run certain things much longer. So with this 8 rows and 4 columns, I realized I was trying to do a shift out and shift in instruction together to get rid of 18 times in each like it'll be running it 18 times in each loop. So which is technically a bit expensive, I felt, because it's like I'm not using a full full matrix like 8x8. So I felt that there might be better way to optimize that. So literally how it works is, I'll just give you a history. So each of the shift out will be, which is 595, will trigger each row, means each pin one by one, turn on each pin to high one by one, and then the input matrix, which is the 165, which is the second matrix here, second chip here, will read those input from technically for each row, or which row it'll understand which switch got switched on, and automatically this will get registered here in the as input, and that's how I detect which button is in press technically. So now it's going to illuminate each and every to high 8 times, and for each it'll read this shift in register one time for each row, this thing, when it's switched on in each loop. So that cost me around 8 shift out and 8 shift in total. So this was 16 total. So while working with the Arduino code, I realized, okay, I can make it much faster since I can reduce the number of holes. So I switched it back to the new one, which is 4 rows and 8 columns. Now what is going to happen is 4 times, only 4 of the pins will be set to high in each loop once. So it will be 4 loops only, and only 4 times this shift in will be called to read the data. So only 8 instead of 16 on the left hand side. So that saves me lots of process time. So I'm trying to optimize the code as much as possible, and I'm avoiding the use of delays. So I made few quite a bit of logic changes with the delays and all. So quickly I'll show you something which is I'll quickly go back to this thing. This is the breadboard, whatever we are seeing here. This we saw earlier. It's like a prototype, everything on the breadboard, and you can see the joystick here. Then you can see the joystick, and also you can see the LCD also connected with all the programming buttons. You can see below over here. And apart from that, you can see the programming buttons over here, the LCD over here, and these are the backlit. I just I'm like kind of demonstrating the backlit using these 4 LEDs. These are run by a MOSFET, and they are PWM control, so I can increase and decrease the intensity. So once I start showing the program, I'll show you how it works. And we have the LCD over here, and then I have turned off the backlit because for some reason I couldn't capture the screen properly with the backlit on, so because of some other environmental exposures, so I had switched it off. So it might be a little dull, but hopefully everyone can see it. And these are the program buttons, 4 of them, and this is a 5-way switch temporarily connected, and this is just the just to check if the 4 pins are firing properly, the shift out. So I just on parallel connected to this LED so that I know whether they have the rate at which they're firing. Right now it's at real time, so you are seeing it a steady light. And while debugging and all, I usually pause 1 second between each loop, and I could see this LED also blinking one by one, so I know everything is working fine. This is just for my debug purpose. I have the 2 of the potentiometer here and the mod switch here. This is a on and on toggle switch, and the on off on toggle switch, 2 of them to demonstrate the logic later. So now obviously I kind of want to make it a little more interesting. So what I did was I'll give a demo a little later probably, but I want to create a menu system in Arduino. So the menu system is technically I'll show you, switch it back to PowerPoint. So this is the menu system I try to create. So I want to have a main menu when I'm in the programming mode. This is the programming instruction flowchart. So this is the program menu. Once I enter the menu, I have 2 options, which is either clock or simulation. So when I check clock or choose clock, it should give me 2 more options, which is timer or stopwatch. So as you can see earlier, also again in the LCD screen, the top right of the first row is reserved for timer or stopwatch. Means I can use it to set timer, like I want to let it beep or reset every 10 seconds, 1 minute, 2 minutes, 24 hours, whatever I want. And that you can set so while traveling through the menu, you have option to set the hour, minutes, seconds, and then automatically set it to timer mode. And if you choose stopwatch, you set everything the clock to 0, and you can start, stop, pause, and reset the stopwatch. And then the simulation mode is like I have this lower lower line of the third or fourth line of the LCD, I have reserved it for programming, and the 2 second and third rows are left free, which I can use for displaying the simulation data. So based on what callbacks of what simulation I want to use, I choose from this menu. I can easily program the Arduino code to adapt to any of the BMS or other, DCS. Using the DCS BIOS, I can activate certain profiles. So I have option for now for BMS, another for DCS. We have certain submenus so that I can choose between generic A10, KA50, MiG-21 and SC25 planes. So I can choose which plane module I want to load, and then automatically this is like a more programmable controller. And then explain, in case I want to choose explain. So I went to online, check various options what to do with this, how to create a menu with Arduino and all. So I was not very satisfied with whatever was available online. I got a few ideas here and there. Then finally I went with my own approach of using pointers, a linked list pointers, which is technically a pointer structure which will know what is the previous node, which is the next node, which is the node above and below, all those. So I created one, and then it works wonderful. So I'll show you once I demo the entire product. Coming over to the demonstration, let me see if I can start the demonstration. Yeah, so this is the So this is the demonstration I'll try to show you. So now let's say, as you can see on the top right, you will see on the LCD right side corner, you will see the this place, you'll see the timers. So this icon here is showing it's a timer mode, which is an R glass, and then this is R minute second it shows. Right now it's paused. Now currently it's set to 10 seconds. So what will happen is, when I press this fourth button over here, which is meant for, has a various function, which is either start, stop. When in non-programming mode, it's start, stop, or start, stop, reset timers. 3 functions it has when it is in non-program mode. So when I say start, now you'll see the timer countdowns to 9, 8, 7, 6, 5, 4, 3, 2, 1. And there is a buzzer which makes a sound also. Okay, and then it resets itself to the default timer value, which is 10 seconds. So I can start a timer anytime. I can stop the timer, pause the timer, and then reset it back to its original value. Now, and here what you see here on top is the mode. You can see a mode, and in that you can see it's kind of a button which is stuck. So it means I'm in hold position. Momentarily means hold toggle switch will be on hold mode. And if I change, flipping this one switch over here down, this particular switch you can see here, if I flip it down, it will show me I hope you can see the switch. I think it's not visible because of the eyepiece. And this one I put it down. Now you can see the button has disconnected, means it's a momentary. Now the all toggles will behave like a momentary switch. So as you can see in the screen bottom left, you can see the game controller dialog, which has this 32 buttons. Now actually I don't use entire 32. I am using only 27 buttons, physical buttons I have on this entire controller, but rest of the 5 remaining buttons are actually virtual buttons. What I'm doing is, when I'm flipping, let's say I'll give a demonstration again. I put it on the hold mode just to understand. So now this one, if I flip up, you should be able to see the this one, the 8 this thing, first row 8 button is lit up in hold mode. And now when I switch it off, you'll notice one of the button below, which I guess it will be somewhere here, 28 or 29 forward, but 20 probably, will turn on for around half a second and switch off. Now the thing with these buttons also, like momentary or whatever I'm doing with this virtual, I am not using any delay in the logic of Arduino to make sure that everything is run real time. So instead of delay, I have another set of pointers, dynamic pointers I create, which is holding the information of which button was turned on momentarily, and I have a constant which tells, okay, I want to hold for how many seconds, like 500 or milliseconds or 200 milliseconds. I can set it there with defining a variable, and what it does is it has its own runs its own loop, and loop is the program loop. It gets executed once every time, and it keeps checking every pointers when was this particular button was activated, and what was the last millisecond was activated, and then the moment which cross the limit of the threshold, it makes sure it switches the buttons off, and then delete that particular point structure from the pointer and free the memory. So now it's very dynamic. And same the logic is used for the momentary also. Now if you can see, now I go to the next button, switch off, again same 28 button is switched on, the momentary. So I have actually 3 buttons. It's working with the toggle switch. When the switch is off, it calls another button, and when it's switch on, it calls its own button, and the same reverse for the other side also. When it's called back, it calls back that virtual button for this particular switch. Now if I switch on the momentary mode, now you'll see when I toggle to the on state, it turns on for only half a second, which I have programmed. I can make it 200 millisecond or whatever I want. Now switch off, same behavior is for the virtual is same, always same, half a millisecond whatever I program. Now the next also, even though it's stuck and always switched on, but it understands a momentary, and just make sure it doesn't keep pressing the button. Now off, and same thing. So it's kind of working, everything works. This one is another set of buttons, and you can see it turns on certain virtual, and everything works. Now mode on, and you can see it kind of works quite flawlessly for me. It's all, and it all perfectly fine. And these are the joysticks. You can see the joysticks working, the potentiometers, you can see it works. And then I have few of these buttons, up, down, left, right, all working. These are all joystick buttons. Now coming over to the programming part. And also, yes, one more thing, when I am not in the programming mode, these 2 middle buttons works as a backlit intensity control. So ideally this is, I call it the menu button. This is the negative or down, and this is up or positive button, and then this is the select and start stop timer button. So now when this is not in the program mode, this entire unit, so what it does is it acts as a brightness controller. Now I can dim the LED, you can see the top LED here. I can dim it, I can brighten it to max, dim it now. Right now I set it to 50 unit stepping of intensity, so I can make it more finer, just give it 2510, but this is just a proof of concept whether it works or not, and it's working perfectly fine. Now let's go to the crux of this entire demonstration, which is the, now let me zoom in a bit closer, everything. I'll try to get a little closer so I see the buttons and the LCD together. Now yes, you see mode, you can see now, I can see much clearer, I guess. So I'll do mode momentary, mode hold, and this is the icon for the timer. These 2 rows right now, I for debug purpose I just set it to LED intensity, means I can at least see, okay, how much is going. It won't go up to 55, and then it goes down. So it's just for debug purpose, but eventually it will be occupied by the simulator. And at the bottom row, when it's not in programming, it will tell you what simulation mode I am in. Currently I am in Falcon for BMS, and yeah, these are numbers here and there are just for debug purpose, nothing to bother. Right now the game logics are not implemented, but I have kept all the options open. Framework is there, so I need to plug the module inside the Arduino code, and it should work out of the box. Okay, now let's start programming. So hit the program button. Now I'll see the main menu, as you can see on the left side, and there's a icon here saying that means I can hit the select button and I can go to the sub menu. So if I hit select, I get an arrow here, means I can still further go to another sub menu, and with the sub menu of clock, and then I see two up and down arrows here, which tells that I have a sibling menus in the same hierarchy, so I can switch between them by using these two buttons. I can select between simulation and clock. So at simulation, if I go, and also you see a back button, means I have a parent hierarchy which I can go up back, like I can go back by hitting the menu. So I'm in main now, and then again go back, and if I hit main again, I exit the entire program mode without doing anything. It's like a cancel. Now I go back to main, I select the clock, or I select the simulation mode. Now sim also, you see obviously has a right arrow, which means I can go further inside their submenus. Then I have option called BMS, but it doesn't have an arrow, it has a tick, means if I hit select now, I'm going to choose the option BMS. And then if I go down, because it has these two up and down arrows here, so it will go to different explain, also has a tick, means I can select explain mode right now. And then if I further go down or up, and I went to DCS now. Now DCS doesn't have the tick because it has a sub menu. It has a sub menu structure, so it will go into more options of DCS. So it has an arrow. So I need to go select, and then it gives me options now. DCS generic mode. So if I go down, DCS A10. Now it has a tick now over here. Means I can now select DCS A10 mode. Then DCS K50, MiG-21, DCS Su-25, and I roll back to generic. So it's a cyclic menu. So I can keep cycling through the entire menu from last to top again without going all the way back. So all the menu systems are programmed to be a cyclic menu within the same hierarchy. Now let's say I want to choose some nice, I like MiG-21, so I say MiG-21 and say okay. Now you can see sim mode is MiG-21, DCS MiG-21, and obviously for debug purpose I say sim mode is sim code is 4. So this code can be used in Arduino to make sure that only those modules are ran whenever they get a callback from the whatever parent services. And yes, so this kind of works here. Now let's show you a demonstration of the clock. So now I go to main menu again, then I dive further inside, and I go to clock. Now I can go further inside clock, and I have two options: stopwatch, which just as a tick, means I can directly go into stopwatch mode right now. So let's go to that. Or I can go to timer, which is arrow, means I have few further menus to go inside timer to program it. Now for now, I'll just go stopwatch and say now watch this icon over here. Okay, this one. Now it will change to stopwatch mode, and all the values reset to 0. Now I can start the, now I'm out of program mode. By just looking at the last row, you can know whether you're in program mode or in normal console, whatever mode, game mode. So now if I press, now that stopwatch starts. I can pause the stopwatch anytime, I can reset it back to 0 and start again, and then stop, reset. Now I'll show you how I program the I can program the clock, the timer. So go inside. Now you have option, okay, how many hours you want to set, 1 hour, 2 hour, I can up plus minus I can do, or I can go to the next I say I don't want hour, minute, I can set how many minutes I want, and this will look between 0 to 59. And then seconds, let's say I want to go 15 seconds now, 2, 3, 4, 5, and then I say okay, don't worry about what's happening here, yeah, those are just for debug purpose. I say okay. Now you see 14 minutes, I think, seconds, I think I said, I didn't set 15. So now it's showing 14. Now I can start the timer, and exactly 14 seconds it will reset the timer as well as send a beep sound also. 3, 2, 1. Yeah, now it sets. Now the reason why I want to include this timer in the console was the controller this is very important when you're flying, because sometimes you want to do a orbit or you want to fly certain distance for, let's say, climb for 5 minutes or 20 seconds or whatever. This will give a very good option to program them, and then you can use the timer or stopwatch to do whatever you want. And I think it's one of very important clock. And usually I know most of simulators have clocks in their cockpits, but those are use mouse and then find it, mouse click and all that. So I thought that having a physical device with your muscle memory can be used to program and make changes is quite efficient than having a clicking mouse all over the keyboard or cockpit, so you don't have to use your mouse as often. And yeah, basically, so this was for the timer, and yeah, pretty much I think this is I think all I have for now. And but I guess after this what's left is making the PCBs. And component wise, I have already made lots of progress and quite all the components, but I think the PCB will be a bit of delay because due to COVID situation now. I stay in Mumbai, but I think next week probably have to go back to my native place, so I'm not sure if I can complete this soon enough. But if ever I make any progress, I will definitely give an update, and hopefully I'll see at least I can finish this project, this particular one, at least even at my native place. So let's see. I hope everything goes well. Stay safe and have a great day, everyone. Bye bye. Thank you.